Welcome back friends to the next tutorial in our practical machine learning series. You are with me Anuradha. So far we have explored the basics of supervised learning. Diving into introductory classification and regression problems, we have taken a deep dive into a couple of linear regression concepts already. In this session, we are going to tackle a real-world regression problem, which is predicting bike sharing demand. And this data set is obtained from public sources, also available in GitHub, along with my notebook, link to which is given in the description below. We'll apply what we have learned and introduce some new concepts. So don't hesitate to code along with me, even if you don't fully grasp every step. And throughout this tutorial, we'll walk through the process used to solve real-world machine learning problem, and I hope you are as excited as me. And so what we are waiting for? Let's dive in and get started. Bike sharing apps has gained global popularity as a convenient and eco-friendly transportation. These systems allow user to borrow bike from one station and return them to another within the same network, typically at a minimum cost. They have some assigned workflow where generally they sign up, swipe out, ride, and dock cycle. Bike sharing systems face several business problems that can be effectively addressed using machine learning. Some of them include forecasting demand using historical data like weather conditions or any relevant factors to decide the number of bikes needed at each station at various times, predictive maintenance, analyzing data from bike sensors to predict when a bike is likely to require maintenance. The other could be implementing dynamic pricing based on demand time. Next could be designing better service plans based on user behavior when they want to rent and return bike, and there can be many. So friends, I am in Google Colab. I've already uploaded the CSV file and also mentioned the variable description over here. I've given references over here which will take you to the problem description, data set, and also the notebook which I have extensively used as part of creating this program. I've imported libraries. If you are new to machine learning and if you have been following my previous tutorials, you might be aware about some of the libraries which I have used extensively in my previous tutorials, which are like pandas, numpy, matplotlib, seaborn, linear regression, and the metrics, right? Apart from that, you might be new to the other libraries which are used in data pre-processing or some of the different algos which belong to linear models or decision tree or some ensemble techniques. So during this tutorial you will be implementing along with me these processes, and once the tutorial is over, I hope you remain not so beginner and level up your machine learning game. So as we know, the first step is load and initial exploration of data. So I've already uploaded data set through pandas read CSV method, and if you see, I have used one additional argument over here which is encoding, and by default if you do we have not been giving this argument, and its default value is UTF-8. Let's see what will happen if I don't use explicit encoding over here. It will give me error that UTF-8 can't decode bytes. So here this file might be differently encoded, and we can try different encodings or we can dynamically retrieve the encoding, but just for the sake of saving time, I have provided the correct encoding over here, and we can upload the data. Now the first step, as soon as you load the data, is to have a first look at data, and you can have a first look at the data through head method, right, which gives you first 5 records by default. Let's have a look at this data set. Each of the record indicates a date information, the weather information based on different parameters, and the rented bike count during an hour on the particular date. Apart from this, we have a couple of more parameters like holiday, functioning day. So during this tutorial, we will be exploring what is the relation of each of these weather parameter to the rented bike count and how important it is in deciding the number of bikes that needs to be supplied during an hour based on the weather condition and whether it is a holiday or not. What are the important features which are influencing the rented bike count, right? So this is ultimately a regression problem where we are going to predict the rented bike count based on important weather conditions for a particular hour. So once we have this first look at the data, right, let's explore how big is our data. For that we can use shape method, and it indicates that there are 8760 records in this data set with total of 14 columns. So once we have introduced ourselves to data, we need to inspect the quality of the data. For that, we will be following certain steps, like starting with overall data information, which we can give using dataset.info command. Info command gives us a summarized insight into the data. How many columns are there, what are the corresponding non-null value count for each column, and what is the data type allocated by pandas to these columns. By default, Panda allocates the data type based on the values contained in them. If it is any integer or decimal value, it will assign it integer or float value, and if it is string value like we have in season, holiday or date, it will assign it object data type. As part of data quality inspection, we need to come up with certain action items and we need to do certain steps. Now, why checking and addressing data quality is important at this stage is because simply poor data quality can lead to incorrect insights, biased models, and unreliable prediction, which we do not want, and our hard work will be wasted if we are building up the model based on poor quality data. So we need to address this as first. To start with further quality check, we can proceed with couple of checks like duplicacy in the records, missing data, or checking for inconsistency. Let's say for checking duplicacy of record, we can give dataset.duplicated, where dataset is our data frame, and it will return all the records, and if there is any duplicated value, it will return true value. There are multiple arguments for this, so we can also do like this. So if it returns 0, that means there is no duplicate record. We'll stop it over here. When we will do future tutorials, we might come across any duplicate data and we will see how to handle that. Let's proceed to missing data. To check missing data, we have to give df.isNull. Okay, if we give just this, what will happen? I'm sorry, our dataset is dataset. So dataset is null. Again, it will come up with each and every column value, and if there is any null value over there, it will return true over there, right? So what is null value? Which has any n value. Now some of the data sets might have question mark or something like that in that, but it will not be identified as null value, and we need to rely on other method for that. For now, if we are giving data set is null, and if we append it with some method, it will give us total null values in each column, which we currently see as 0. So for now, there is no missing data over here, and hence we do not need to handle it. So we do not need to handle missing data over here. Don't worry, upcoming projects, we might need to handle missing data or duplicate data. The next step for checking quality is check for inconsistency. So what is inconsistencies over here? Data inconsistency term is self-explanatory, right? But to dive in, these are the errors in dataset where information does not match across the examples. Let's say we have in country column we have USA written in some places, while in some places we have United States. Or we can have different date formats like 01/02/23, or somewhere it is like hyphen separated. Why there are in data inconsistencies in dataset? Primarily because of human errors, okay, and they can be there because of manual data entry like typing mistake or inconsistent formatting or like different terminologies used by different humans, right? There is no standardization of data. Can be coming because of merging of different data sets which we have not talked so far, which we have collected from different sources. Okay, so these are data inconsistencies. And how to check for data inconsistencies? We will just see an example for categorical columns like seasons, holiday, and functioning day. And we will also have a look at date formats. So right now we do not see any numerical column where we need to check inconsistency over here. Like if we would have got a column like age, which is a numerical column, we need to make sure there is no age which is lesser than which is lesser than 0 or maybe above 100, right? So, or there are no outliers in that. But coming back to categorical columns, which we have date, season, holiday, functioning day, we will be checking only for 3 columns: season, holiday, functioning day. Why? We need to convert date into date time format. We need to change the data type of date column to a date time type. Alright, why? That will help us to perform various data manipulations such as extracting year, month, and when we change it to date time type, it will also ensure the data consistency issues which come up due to mixed or incorrect date formats. Alright, so we will do that later. Let's just have a look at how to check inconsistencies in these 3 columns, and that we can, let's take example of seasons. We can pass to it unique method to check what are the unique values, and here we see that winter, spring, summer, there is consistency data. There is no typing mistake over here. There is no problem of standardization, so this is a consistent value. Similarly, we can print for others also, and we see there is no data inconsistency. There are 2 values of unique values of holiday and 2 unique values for functioning day. There are 4 unique values of seasons. Now what looking at these unique values also leads us to action which we will be doing during data pre-processing, which is categorical encoding. We will understand more about that. What we understand that looking these values, these are nominal in nature, how many unique values they have, and that leads us to what kind of categorical and encoding needs to be applied over there. We will go into that when we are into data pre-processing. So what are the observations and actions at this point? Is there are no null values, no inconsistencies, no duplicate record? So we do not have any work, right? No, we do have a lot of work. And then holiday, and these have unique values, 2 unique values, seasons has 4, and of course we talked about it that data type of date needs to be changed. Okay, so let's have one more final look into the data before we proceed to next step of data wrangling. Let's just have a quick look at this data set statistics. And if we have a look at this, it will give us statistics about numerical columns, and we can include categorical columns as well. Let's just stick to this. If we give .t to it, it will just transpose the information, which will be easy to read. So we can see that these are the total counts which we know, and what is the mean of rented bike count. If we sum up all the rented bike counts and average them out, this is the mean. What is the minimum value? So 0 is the minimum value, maximum value is this one, and the value at the middle, which is median, is this. So 504 is the median value. So we can clearly see there is a lot of difference between the maximum value and the last 75 percentile value, which indicates there are outliers in the data. Plus from these values we can also see that the data is that, let's say, this rented bike count. If we see the mean value is 704 while the median value is 504, that means mean is tilted towards the outliers, and this gives us the hint that this is positively skewed or right skewed data, which we will be understanding more when we visualize the data. But this textual information gives us some storytelling about the data, that there are outliers, it is positively, whether the data is positively skewed or negatively skewed or normally distributed. Let's see the example of hour where mean and median are almost equal. That means this data is normally distributed. And why we are looking at this statistics? Because we need to perform a couple of steps related to data transformation or normalization during data pre-processing, right? So we need to have insight about data statistics. We have already derived actions, and we will be moving to next step of data wrangling. So let's proceed further. So data wrangling is a step which comes after data collection and before exploratory data analysis. We didn't do any data collection as such. It would have involved gathering raw data from various sources such as API, web scraping, or manual data entry. We just use published data, right? So what do we do in data wrangling? We primarily do actions which we defined as part of data inspection, handling missing data or duplicate data or data type conversion, right? And apart from that, the main purpose of data wrangling is to clean, transform, prepare the data for analysis. We make it the raw data in the usable format which we can analyze, and we finally also have on our plate what are the numerical columns and what are the categorical columns over here. So first of all, to proceed with data wrangling, since it will involve lot of data manipulation, cleanup of data, removal of values, we will make a copy of original data set to keep the original intact. We will create another data frame, use original data frame, and just have a copy method associated with it, and it will give us the same data set, right? And which we can see with the help of df.shape method. Alright, so we have same data, but we will not be touching upon data set, the original data, right? And now is the time to clean data. As part of cleaning data, we just identified one activity which was changing the data type of date. We don't need to, since there are no missing values or duplicate records, we do not need to handle them. So all we have to do is change the data type. So we will access the date. We will use the pandas method to underscore date time, pass to it the original value, right, and assigning back the new value to this. Let's see what happens over here. Now this gives us error. It may not give you some error always. It will give you some error sometimes depending on the date format used in the original data frame, and we need to explicitly give it argument of date format, which we can give with the help of format method. So let's run it. And now if we run df.info, we'll see that the date time has changed to. What is the benefit of doing this? As I earlier mentioned, we can easily extract values, time related values from this, like month, feature, week, and more. So next we move to extracting features from existing feature, which is date. This activity is called feature engineering. So feature engineering is the process of creating new features, okay, simply, or modifying existing one from the raw data. It is ongoing activity. Simply, as we will proceed, we will be doing feature engineering again and again as part of maybe EDA, data pre-processing, as and when we identify the need. The main purpose is to get the more insight and to make it suitable for analysis and also for machine learning modeling. So here we are doing feature engineering as we have identified the need of extracting a month or day name from the existing feature, which is date. First, let's do that and we will see how it is helpful to us. I would like to notify that as part of data wrangling, there is no prescribed steps as such. These are very specific to the project needs. What ultimately we are doing, we are making raw data suitable for analysis. All right. So how to extract month? Let's say we create a feature called month. Okay, so we have our data frame and we add to it new feature called month. Okay, and we are extracting it from original column which has converted to date time, and we can simply use dt method on this to extract so many things. As if you see the option, we can extract day, day name, day of week. So many things are accessible to us now once we have converted this date to date time. So let's extract month. I will extract month name. If I would have extracted month, it will give me the number, and if I extract month name, it will give me the name of the month. So in analysis, I feel that month name can be more relatable, so I'll just extract the month name. So it gives you various values, right, corresponding to each record. Let's just see the few values. Okay, I'll just do it sampling, so it can pick the random values. So let's say I sample out 5 values, so it will not simply give top 5 values, just pick up any 5 values from this, and we can see we have got the month feature, right? Similarly, I want to analyze the effect, whether it was weekend or weekday, what, or is there any effect of rented bike count on the, does it matter whether it was Friday or Wednesday on the rented bike? What features we can derive here? Month, day name, whether it was weekend or not. So let's do that. So I will update this, so I will just update the code over here to extract all the temporal features which I want. Temporal features are the one which are related to time. Okay, and we have this information. Let me add one more feature, is weekend, okay, which identifies that the given day was weekend or not. I want to check whether if it is a weekend, does it affect the demand of bike. Okay, I'll simply extract the weekday from here. It gives me the number of the day. What does that mean? There are total of 7 values in weekday, okay, starting from Monday. So Monday is 1, and going forward, Saturday arrives at 6 and Sunday at 7. So all I have to do, check the weekend. I have to give a condition over here. If it is greater than 5, all right, it is a weekend. And let's see the change in values. So it gives me true false value. If it is not a weekend, it will give me false value. Now let's see the change in our data set. So if we see, we have 17 features now, right? And now date is redundant. We do not need date anymore. We might like to drop it further. And we have added month, year, weekday, is weekend, four additional features to it, right, which we will be utilizing while doing exploratory data analysis. Also, one more thing I would like to do is, like, here hour is counted as like numerical value, which is correct, but I would like to put it in category of categorical variable for the purpose of analysis. It is simply, it has limited values. We cannot have a value of hours beyond 24. So let's just see the unique values of R first, whether it is in 24-hour format or 12-hour format. So it gives me 24-hour format, and I would like to change the data type. df hour is equal to dfr, and to change the data type here, I'll just pass s type, and I'll pass a special data type which is called category. If we run this df.info again, okay, type of hour has changed to category. In fact, year need not be any number value, it should be categorical data type. We can change the type of year also. And if we run it again, if you see, the type of year has changed, right? Perfectly fine. Now everything seems to be in place right now, and if it is not there, we will realize it and we will come back to it. So for now, we are at the end of data wrangling, and it's time to extract categorical and numerical variables identified from the list of columns, and that we can do with the help of data type, select data type. Let's see. So in df, we will do select underscore d types, and to this we will pass include is equal to, and the data types we want to include. So we have primarily two in mind. One is the one which is object, which has data type object, and the other which has category object, category, right? And let's see what we get out of this. We get whatever is in the record, right? Whatever columns and have these kind of objects, it will be returned to us as records. But what we want to extract from this data frame is just columns, right? Let's see what we get. We get this, right? Now all we want is to have a list of these columns, right? So I'll just use toList method. And similarly, what I can do, I can also extract numerical data in the similar manner, and I'll name it as num underscore call. So I want int and I want float. Let's see what we get in num call, and I get these columns. Let me just print it. So now by the end of this data wrangling, we have clarity on what are our categorical columns, what are our numerical columns, and now we will proceed to next phase of this ML modeling process, which is EDA.